Hi, today I'll be going through the sorting algorithm of MergeSort. It's being developed in 1945 and similar to Quicksort, it uses the divide and conquer algorithm. There's two different implementations to it, the top-down implementation and the bottom-up implementation. The main idea of MergeSort is to divide an unsorted list into n sublists, each containing only one element. Each sublist is considered to be sorted because there's only one element. And now we'll be merging and sorting two sublists and forming one new sublist. We'll be repeatedly doing this for all the sublists until there's only one remaining. The bottom-up approach. The bottom-up approach is a way to do it without using recursion, while the top-down approach would be using recursion. The main idea is to assume that we already have n sublists with one element, and we'll be going up the list by combining two sublists. This is the example that we'll be dealing with to visualize MergeSort. Firstly, we'll be breaking them up into n sublists containing only one element. As you can see, 10 is one sublist, 7 is one sublist, 2 is one sublist. Now we'll be combining two sublists into one. So 10 and 7 will be combined and sorted. So it becomes 7 and 10. And so goes on for the rest of the sublists. This goes on. And as you can see, what happens if there are an odd number of sublists? Well, it just happens that the very last sublist would have nothing to pair with and just be passed down. It goes on and on until there's only one sublist remaining, and that is the sorted list. The stability of MergeSort. If the sorting algorithm is unstable, it means that for any item that's ranked the same, the order is not guaranteed to be the same as the input. For example, if there are two ones in the array, for example, the second one being input from the user might not turn out to be the second one in the result. MergeSort is a stable sorting algorithm as it evaluates the element based on its order. So we'll be dealing with adjacent elements at each time, and we will not mess up the order. Time complexity. As you can see earlier, it takes log n number of times to get from a n sublist to one sublist, and for each time we will be recursing through n number of elements. So the total time complexity for MergeSort will be n log n. We will now be looking at the code. This is the code for MergeSort. First of all, print list. What print list does is to print the original state of the array. There will be another variable called box, which would be an empty array in the beginning. We'll be using it together with the array input by the user data to print out the results. In this for loop, what it does is that it determines the size of the sublist. As you can see, it starts off with 1 and it moves on to 2, 4, 8, 16, for example, so on and so forth. This is the size of the sublist after it's been combined. It will then be passed down to this method. What this method does is that it sorts and assigns the different different elements together. For this for loop, it checks that the total number of elements remain under the total number of elements that's given by the user. Whereas for this for statement, although it's a bit confusing, basically what it does is to compare the first sublist and the second sublist, and whoever has a smaller value would be stored dummy array. Yeah, and that's it. The array is being sorted and we have our sorted list. That's it.